Alrighty then. Okay, let's go ahead and get started. So, good morning, everyone, or evening, or afternoon, whatever time it is with you. This is the May meeting of the CentOS Automotive SIG, where we talk about all things automotive, in particular, the automotive stream distribution that we create and curate. And this meeting happens once a month. It's about a half an hour because that's usually about as long as we take. And we can just go ahead and dive into the technical status. So, Leo, do you want to go ahead and talk to us about this blueprint that's going on?
Yep. So, as some people already know, SOFI has something they call a blueprint. That's basically a document that describes how to deploy, install, and run something in a SOFI OS compliant operating system or image. What I'm working on is a blueprint that describes how to use a Kubernetes workload to define applications in an auto device and run it. In this particular case, it is describing how to use that with Quadlet with their own UL reference implementation. So using the same YAML files to deploy and run applications on different reference implementation with SOFI. It's almost finished. That's what I need to do is to actually provide some kind of a simple CI script that can be used by SOFI, so they can use on both operating systems.
Okay, fantastic. For those who don't know, SOFI is an initiative within ARM. It's a special interest group that's actually run by ARM themselves to create a cloud. They're calling it a cloud native SDV architecture, software defined vehicle architecture. But it's actually the EE stands for embedded edge. So they expect that this will eventually be useful to use cases even outside of automotive. Anyway, it's a very interesting group, and one of the things that they do is support blueprints. You know, they've got an entire group of folks who is working on a reference implementation, specifically for to implement this architecture. They're doing it using from source-based building from source directly using Yocto project. They call that EWAL, EWAOL, and EWAL and AutoSD, which is what we do, are the two projects or distros or whatever you want to call it that are compatible with the SOFI specification. So this is very interesting. I think it's going to be very interesting to folks who want to use container orchestration within this architecture, but do not want the overhead of Kubernetes. So great, thank you. And you got some SDV image updates as well.
Yeah. So
oh, wait, we got a question. Right. Joe is also working on SOFI projects. Good.
Yeah, I've been working on their containerization projects for SDV.
Okay.
It's a good thing. I think they have a lot of projects. Only thing it's ARM focused, but nevertheless, I think in SDV this is the future. So
for sure.
About Eclipse image, I joined the Eclipse SDV meeting call on yesterday. This was actually no, that was a group that they call SDV distro use cases. That's going to be renamed by SDV blueprints or something similar to blueprints. Okay. So they are kind of assuming a similar naming convention as with SOFI as well. So the groups will be more about blueprints and so on. So I was the what they are looking to a use. So Bosch is looking to a use case of running uh, Cooks and several other Chariot and
Mm,
several other Eclipse projects. So I'm basic. So I'm what I'm doing is I'm analyzing what's the effort of running Cooks on our Eclipse SDB image. So we have a similar uh, we have a similar use case built on our AltSD image for Eclipse SDV.
okay, excellent. SDV, Eclipse SDV, of course, is a working group within the Eclipse Foundation that has a lot of members and is working on a number of different software projects. I believe we're up to 21 software projects, of which I think 19 have been officially accepted. And of one of those is Eclipse Kuxa, which I think started in Eclipse IoT, if I'm not mistaken. Anyway, these are all of these are building blocks for software-defined vehicles, but Kuxa is probably the most mature of all of these projects. So yeah, I think that getting that running on AutoSD would be fantastic. It does say it's already compatible with a Raspberry Pi, and that's our primary hardware platform to date. So
That's
yeah,
all I had
any
update-wise.
okay, great, thank you. Um, any other questions from the group on Eclipse SDV or the Sophie blueprints? Be glad to talk about those things, or actually anything that anybody wants to talk about. Very quiet group this morning. Morning where I am, sorry. I realize it isn't for everyone. So, well, one thing we don't do very often is just kind of go over what we are actually trying to accomplish with this special interest group. So maybe since we have 20 minutes, we can go ahead and do that. Special interest group is within CentOS, obviously. This is a kind of a graphical map of how packages flow into CentOS as a distro on their way between Fedora, which is the upstream, very large sort of experimental project at the top, through CentOS Stream, which sort of um, it repackages things and sort of boils them down and brings them into the enterprise world and provides a seamless contribution path towards Red Hat Enterprise Linux. So there's a better diagram down here. It kind of shows that CentOS Stream is actually the direct upstream from Red Hat Enterprise Linux. In the same way, we in the automotive special interest group, we create a distribution called the Automotive Stream distribution, which uses CentOS Stream components. It's very much derivative of CentOS Stream. And eventually, this will lead to a Red Hat in-vehicle OS product that has not been announced as far as a release goes, but it's something that we've been working on for a couple of years now. Package flow is also very interesting, I think. It shows that open source projects start in the open source world, of course. Fedora has been a great kind of centralized distribution point for a lot of open source projects. I don't remember how many packages there are in Fedora now, but it's many thousands. It goes through ELN, which I actually don't know that much about. If you want to fill in, please feel free.
I can tell you a bit about ELN.
Oh, sure. That'd be great. Yes, thank you. Thank you, Sandro.
Yeah, ELN is an effort of preparing packages the same way they are built within Red Hat. So it has been announced as El Niño with the reference to kids in Spanish. world, but it's also Enterprise Linux Next. So
I see. Okay.
it's the way that a subset of the package of Fedora are taken and built with the same system that we are building the package within Red Hat. So currently, ELN is pointing to what will be Red Hat Enterprise Linux 10, and it will be converted to CentOS Stream when we start the bootstrap of Red 10.
I see. Okay. Yes. The best couple of minute explanation I think that I've heard. I don't think I really understood it before this. That's really good.
And I believe that's managed by the Apple SIG group, right?
Not sure.
No.
Okay. Apple, of course, is extra packages for enterprise Linux. All of the stuff that goes into that is available for Fedora that isn't specifically curated by Fedora. So, from ELN, these things eventually flow down into CentOS Stream, where they are built as a streaming distribution, and they are available to the CentOS SIGs, including the Automotive SIG that we are in right now. And if this functions as a direct upstream into Red Hat Enterprise Linux, which of course is Red Hat's productized version of this operating system. So I hope that is both clear and interesting, and kind of shows the very large scale effort that goes into all of these packages, making sure all of these packages are in good shape and ready for enterprise level workloads.
Hey, Jeffrey, I've got a question
Mhm.
on the previous slide. Can you explain to me the two arrows going into the in-vehicle OS product? I mean, I get that Rail would be kind of the upstream of the in-vehicle OS, but you've also got another arrow from the auto stream distribution.
That's very good, very observant. What that I believe that indicates is the kernel that we use, which is slightly different from the kernel that is produced with RHEL. So there is a package within the CentOS Automotive SIG. Let's see if I can go find it quickly. What do you want to bet I'm not going to be able to find it quickly?
Is there a chance also that there are going to be packages like Kerte that will never be available in RHEL, but only in Ribos? That's been decided yet?
I don't think that that's been decided.
Because I'm working on packaging up QM right now, and that's probably in a similar boat. I don't see where QM would make much sense for. But maybe for edge devices, I don't know.
Yeah, I honestly don't know. But anyway, this is the kernel. There is a special kernel specifically for automotive. It does have real-time turned on. The real-time patches are applied. Actually, there are people on this call who could speak much more clearly to that than I can. So if anybody wants to talk a bit about the automotive kernel, that would be great.
So the packages come from RHEL and the kernel comes from the stream, the automotive stream.
That is my understanding.
Okay.
Yeah, there may be also other packages that will be built within the automotive SIG that will land into Ribos and not in RHEL. But that's an option.
Just to speak to the automotive kernel to explain, it's basically the RHEL kernel plus the real-time patch set, and there's some extra kernel config options turned on, and there's some kernel config options turned off, but it's 99% the RHEL kernel. You can think of it as the real-time RHEL kernel.
John, does that help?
Yes, thank you.
Sure. Okay. Well, does anybody have any questions
Right,
for
but
the
that
group
was kind of the eventual goal. And it's okay, well, that there's a framework that had the that's both in AWS and it would be new.
I would like to ask, is there anyone in this meeting that is looking into integrating their own software on top of Automotive SD?
So we are trying to do some our own OTA implementation on the board. We are, as a homegrown stuff. We're trying to do that on Orion boards actually. We are using Zen as the hypervisor and then doing it.
Yeah, I'm thinking just the one-off SRE needs to check something.
That's interesting. Did you got enough documentation on how to get into delivering your software on top of AutoSD? Or is there something that
Yeah,
can be
the Orion boards have it. The NVIDIA Orion boards have good amount of documentation. You can actually, so what we have taken the open source Zen and then writing OTA for that. So basically, the catch here is the licensing models of most of companies like Excel4 or these variants, right? They have a very high cost, and if we were to bundle that price with a car, it turns out pretty big, and then there is a follow-on cost also which comes up. So we're trying to build an open source environment purely to manage a cloud car kind of initiative.
Sounds good.
Yeah, we are also looking at leveraging CentOS AutoSD. As today, we are still based on the RHEL, in fact, because we just rebuilt all the package from RHEL, which is in fact equivalent to Alma Linux 8.6 and 9. I think the big difference we have with your approach as today is that we still use the kernel from the vendors. And in fact, that's something potentially we could present to the group, which is how we migrate a kernel from a Yocto to an RPM environment, and we use Koji to rebuild the full system. And clearly, we are very interested in leveraging especially a binary ready package, especially for the stream version, because it's a nightmare to rebuild continuously.
A question about rebuilding the kernel from the Yocto part. Is there something in the automotive kernel which is missing that is required for your software to succeed?
I would say yes and no. All the real project, I'm not talking about development, okay, but all the real project we have typically are running on custom hardware, which means they have a specific device. Potentially, they also have some proprietary code, like firmware that you have to install. And clearly, they want to skim down the kernel and remove everything they're not using. So, in fact, what we do is we use the standard templating from Red Hat, CentOS, and we just inject within this template, the specificity of the kernel the people need. And from that, we rebuild a specific image using Koji in a cross environment, because we are running in cross environment. So clearly, we are extremely interested in having a source of package that could be used by the community to boost development. So yeah, and currently I'm working on the CAN acquisition, okay, because that's also something that is needed in the automotive sector, is to have some key elements that are solved out. CAN acquisition is clearly one of them. Boot time is another one. Have documentation to implement easily secure boot. So the list is pretty long. And so we have a clear separation between what is usually specific to a project and what is generic. And what is generic is typically the package, especially all the middleware package. And potentially the kernel source code or the kernel version could also be generic. Unfortunately, most of the people we are working with today are still depending on the support from the vendors, the board vendors, which means that very often they are still forcing us to a specific version of a kernel. So for some people like Renesas, it's pretty easy because they have very clean kernel and everything is upstream. For some others, it is a nightmare, like Qualcomm or Broadcom. And I would say NXP and TI is somehow in the middle.
Mhm.
But yeah, we have, and as today with Red Hat, we support more than 10 boards. I think 6 or 8 of them are open source, so you can download as a raw image, or what you could call the immutable operating systems that allows you to install directly the package from CentOS or Red Hat.
Understood. Yeah, I was thinking that having to rebuild the kernel will kind of make things more complicated when you need to get the world solution certified for automotive. Because the thing that we are doing with Rivos is getting kernel API and the other libraries API certified for automotive. And introducing a kernel which is not the one that has been certified will complicate things on certification time.
But even before the kernel, you have U-boot, okay? Because we also typically recompile U-boot, either to implement some specific feature to do some hardware testing, or just to fasten the boot, okay? Because or you want to rewrite the device tree because you're not using also hardware on the board, and so you're willing to isolate some part of the hardware. So for us, kernel config or U-boot configuration is just a standard config within the full project.
It's kind of not sure that you will be able to do that, but would you mind trying to sum up the pain point that you are encountering with the U-boot and the kernel part that's shipping in the CentOS Auto SD, so we can get an idea of things that maybe can be improved on what we are shipping in.
This is what I said. Or it's a pretty long story, so we're not going to make it in 5 minutes.
Yeah, exactly. So writing down something like that will help.
If some people are interested, we may have a video conference on that subject where we present how we do it, and we've done it recently for some customers, so we have the slide ready. We just need to remove some names, and it would be ready to go. So yeah, we can organize that more or less whenever you want.
Sure, we can even book that for the next Automotive SIG meeting if you like.
If you want, yeah.
Okay.
Just asking, is there any automotive vendor who's looking into this and plan to have a look at CentOS Auto SD as a preview for their own automotive vehicles? I guess no.
Possibly not on the call.
Okay.
Even if they were on the call, they would not tell you. Okay.
Maybe not. Maybe not.
But that is the scope of the community, right? Having the people that will use it to preview what will come next. So.
But it might also be an interesting question to ask in the context of Sophie.
Yeah. Agreed.
Yeah, we definitely want to make sure that what we're doing is interesting to as many people as possible. So, okay, great. Well, we have about 3 more minutes, and I can actually stop presenting. If there's anybody has any other questions, we can certainly entertain those in the next few minutes. One thing that might be interesting to cover in a future meeting also is the use of this project outside outside the scope of automotive, because I know that the use case itself is the embedded edge diagram that I showed from Sophie is applicable to a number of different industries, industrial, other transportation industries like trains, and I know that Boeing has recently started a working group within ELISA to try to work on functional safety for avionics. And so I'm hoping to meet up with them next week at the Open Source Summit.
At least on our side, we already use it, not only in the automotive sector, but in the energy sector, the maritime sector, as the military sector, and the avionics sector. Okay, so unfortunately, most of those industries are pretty secret about the subject. But we don't use it in a critical environment. You know, it's not safety compliant. For example, on the helicopter, it is only to collect the data from the helicopter and then to, when the helicopter is landing, then to push all the data for maintenance and introspection. So yeah, it's still the early days. You know, the safety remains a major issue depending what you want to do, but clearly, yes, it's not limited to the automotive sector.
Well, that's really great to know. I love the field stories.
In fact, anything that collect data, take the data, do some, local analysis, and then send some result on the cloud is where we use this solution. Yeah.
Very interesting. All right. Well, we are just about at time. So, Philip, I will be in touch about doing a presentation in about a month.
Okay.
And we'll just go from there. So thank you, everybody, for participating. Thank you for your interest in the CentOS Automotive SIG, and we will see you all in about a month.
Thank you. Bye-bye.
Bye.
Cheers.
Take care.
Bye.
Thank you.